Fermat's theorem. If f has a local maximum or minimum at c, and if the derivative of c exists, then f prime of c equals 0. And we use this already on when we were looking at a third degree polynomial function. But again, basically, let's take a look at any function, just randomly drawing a function. And we're examining local minimums and maximums that would occur at this 1, 2, 3, 4th location. So these are local minimums and maximums, and on every one of these, the derivative is defined. And it's clear that if we were to draw the tangent line at every single one of them, that tangent line would be a horizontal line at each and every one of them. So basically that's what Fermat's theorem is telling us, that the derivative, if it exists at a local max or a local min, then that derivative will equal 0. However, it's possible to have a graph that has a local max or minimum, such as f of x equals the absolute value of x. So if I was to draw this graph, just making a quick rough graph, please excuse my penmanship. This graph has a derivative at its vertex, and that vertex is 0, 0. But the derivative is not defined at x equals 0. And again, this goes back to piecewise functions, because to write this function in a way that I can take the derivative, I would have to say on the left-hand side, it's defined as negative x, where x is less than or equal to 0, and it equals x where x is greater than 0. But when I take the derivative, it's very important to note that it is negative 1 only when x is less than 0. I cannot include x is 0, and it equals positive 1 when x is greater than 0. So even though the function's defined at 0, its derivative is not. So we come up with a way of talking about all points where the derivative either equals 0 or is undefined, and we refer to those points as a critical number. So again, a critical number of a function is a number c in the domain of f that either the derivative at c equals 0 or the derivative of at c does not exist at all. So over here, the derivative goes to 0. These are critical numbers. Derivative goes to 0. This is a critical number. That allows us to rewrite Fermat's theorem. So now I can say that if f has a local maximum or minimum at c, then c is a critical number, which gives me a little bit broader definition than Fermat's theorem, or a little broader theorem, I should say, than Fermat's theorem. So when you're looking for a local max or local min, you must find all the critical numbers, which are where the derivative goes to 0 or where the derivative is not defined.